Well, good afternoon, everyone, and thank
Now I can't hear you, Rich. Test, test. I lost you, Rich. Oh boy. So Brett's talking right now. Can anyone raise their hand to see if you can hear me? Aaron can hear me. Rich, we cannot hear you currently. Anyone else? Well, welcome everybody. This is Brett Zerba. Yep, I see some people raising their hand. For whatever reason, Rich, we lost you. So hopefully we get you back because we all miss you. Oh, you left. Or did I leave? Oh, Jesus Christ. Test, test. Who's I'm not sure who's out there. Rich, are you able to talk? Well, good afternoon, everyone. This is Brett Zerba with TACO. As you can see, I think we're having issues. So again, can anybody? I see Aaron Johnson. Can you raise your hand, or any Aaron, or that you can hear me? Okay, thank you, Aaron. So this is Brett Zerba with TACO Comfort Solutions, and today's webinar is going to be on HVAC pump fundamentals. TACO Tuesday. Hopefully, Rich joins us at some point. He was there. But I don't know where he is now. So I can't hear you, Rich. So I'm going to keep going. It looks like people can hear me, so I'm just going to keep going. So again, today's presentation is on HVAC pump fundamentals. I will try to monitor the questions as best I can, and maybe we'll hear from Rich at some point. Oh, good. I can see a lot of people said we can hear you. Well, that's good because I didn't know when you talk, it says Rich is speaking. Oh, that's fun. 2024. Welcome to 2024. I'm getting a little snow here in Beverly, Mass. Not too bad though. A lot easier than what we thought. So hopefully we can hear you. Thanks, Eric. All right. So today's presentation is going to be on HVAC pump fundamentals, and no PowerPoint. We can hear you. All right. Now I got to try to figure out how to get the PowerPoint up. Oh my God. Oh my God. Oop. Now Melanie says she can see PowerPoint. Audience view. There's the PowerPoint. Hallelujah. Oh my God. We're crazy today. So let's get going. Thank you, Melanie. So today's presentation is on HVAC pump fundamentals. And I see it looks like Rich might be coming back, but who knows? We can't hear you, but I'm going to keep going. Let's get ready. Before I want to recognize my good friend and mentor, Rich Medeiros. He was at the 2024 Shrave show. He was a great a great award, the Dan Houlihan. Surprise to Rich, he well deserved. And some of you may know the name Dan Houlihan. He's been in the industry for many years. People are saying maybe weather body and hard to hear Brett. I apologize. I don't know what else I can do to keep this going. Legendary pumping made easy, classic hydronics. The phone is breaking up really bad. Hold on, I'll try to fix it. Options. Audio is choppy. Not sure if you're experiencing the same issue. Yeah, chat.
Test. How about now? Can you hear me better? I have no video. Not sure exactly what's going on today with the presentation. Audio is horrible. Sound check. Test. Matt says it's better. I can hear him now. It's much better now. So I'm going to try to get right into it and keep going here. I apologize for our little snafu. So let's get right into it. And here's some common terms in our industry. We call them pumps. Many of you may know them as pumps, and obviously that's what they're known as. But you may hear centrifugal, rotodynamic, circulator. Those are the smaller ones, but they all mean the same thing. In the HVAC industry. I remember when I started in our industry long time ago. You sit in meetings and you're overwhelmed, and they start throwing terms around, and a lot of times these terms mean the same thing. Design flow, gallons per minute, right? I'm sure most of us know what we're talking about or understand what that is. Design head, that's feet. System resistance, head loss. Really, it's stuff that you should be familiar with, or if you're not, I'm sure you can learn more by Googling it. It's the loss through the piping and valves and components and stuff like that.
Fred, I think I'm back.
I hear you, Rich.
Can you hear me okay?
I can. Can you hear me?
I can hear you.
Hello? Okay. I'm going to just keep going.
Yeah, keep going because
right.
I think I've got a problem.
Yeah. Non-overloading, that's really on a pump curve. It's probably in a lot of your design specs, the motor horsepower over the whole life of the curve, or the length of the curve needs to be non-overloading, another term that's in our industry. Closed loop systems, and really that's 80–90% of our of HVAC hydronic designs is a closed loop system. That means it's not open to the atmosphere. Open loop system is open to the atmosphere, and your calculations are different. Your calculations are different for your head loss through the system. And you really need to be aware of that, and your design team or somebody in your office or yourselves need to make sure you understand that. And usually an open loop system is a condenser water system for the most part. And there's a little picture of what you might see on a screen for pump selection, or that's the information you see on schedules and stuff like that, really. Design flow, design head. And I'm showing US units, but there may be some folks out there that use other units that are way out of my league. I know what they are, but I don't use them too often. Here's some more points. I said design point, pump efficiency, pump brake horsepower, all terms in our industry that you should be familiar with. And so hopefully, hope you are. Pump efficiency is output power divided by input power. Brake horsepower is the power required to drive a pump. Pump affinity laws, I'm going to show you what those are. Some more common terms. System curves. If you look on drawings, you can see that. ECM, that's becoming a little more prevalent, especially for the smaller stuff, maybe 20, 30 horsepower and less, electrically commutated motor. The industry is going to try to go in that direction. It's not that easy, but many pump manufacturers, TACO included, have them for maybe their circulators and their smaller commercial pumps as well. VFDs, variable frequency drives. Many of them now are mounted right on the pump. A lot of manufacturers offer that, and some of them are smart enough that they can speed up and slow down the pump without any outside influences. So keep that in mind. And then closed coupled pumps, split coupled pumps. So these are all terms that are very prevalent in our industry. Hopefully you're still out there, Rich, but I'm just going to keep going.
Can you hear me now?
I can.
Wow. Technology is amazing when it doesn't work.
Yeah, it's better when it works. I don't know what the hell happened.
Better when it works.
Did you see this nice picture?
Monitoring the questions now, and so hopefully if somebody does say something.
Yeah.
And so just let me take a 5-second break here. Can you folks hear me out there in computer land? If you can, just type in the question area.
Oh, great.
Getting lots of yeses. Well, thank you for that. I appreciate it. It took us a while to get all the buttons running, but we got them all running.
They'll still get their PDH certificate, even though we're screwing up here.
Even though the technology is out to kill us today.
You want to comment on the picture that's on the screen, or you want to just let it go?
Ben looks good.
I like that. I like that. I like that. That's true. Ben White, Johnny's son, one of the White family members, presented Rich with that award. You like that word, Tony? I said I got a spelling error, Rich. Do you see it on the screen at the bottom?
Yeah, I thought that was a new type of pump, the slick.
Yeah, that's the new one. Thank you, Tony, for how do you spell it? Let's see, P-L-I.
Yeah, there we go.
There we go. I did it. Here's the pump affinity laws, and really it's the relationship of stuff in our industry, right? Flow changes directly as a change in speed or diameter. Okay, that's a direct one. Head is the square. Horsepower is the cube. Get yourself comfortable with these, and you should be able to at least understand them. They don't always come up, but they are used by pump manufacturers and looking at curves and stuff like that quite a bit. And here's what a pump does, right? It creates a differential pressure, a delta P. Water flows from higher pressure to lower pressure. I had to take a sip of water. Water, the delta P, right? And another terminology, right? Differential pressure induces flow against system resistance. And then again, in an open system, it also has to lift against atmospheric pressure and gravity. So there is an added thing. But keep in mind, in a closed loop system, right? 6-story building, 10-story building, right? You got a chilled water pump down in the basement or down down on ground floor. It's got to pump up to that 6th floor, 10th floor, whatever. And that height adds, you don't need to take that height into account to get your resistance, okay? What goes up comes down. Obviously, lengths come into play and stuff like that, but the height doesn't necessarily. It does for pressure, overall pressure in the system for your components, but not for that resistance, system resistance. So sometimes that's a clarification that we want to make sure understand. So I just to show it again, open and closed systems and whatnot. So here's the components, the general components of a centrifugal pump, HVAC hydronic pump, rotodynamic pump. Okay, there's the suction or the eye of the impeller. That red, I'm going to say it's red. It could be a different color in your eyes, but that's
You know,
the
it's reminiscent of Valentine's Day.
That's true. I did change it to pink.
Yeah, I know.
Valentine's Day.
It's for roses.
It's roses. I gave my lovely wife Roseanne some roses yesterday. She said, "Couldn't you wait till Valentine's Day?" Well, you know. Anyways, the volute or the casing, that's really the heavy component there. Sometimes you'll just hear it called the casing or a casting or the volute. Mostly it's cast iron in our industry. The impeller, the diffuser or throat, that's where, you know, this kind of formation right here that goes out, the discharge. Most of them are flanged, to be quite honest, in our industry. And cutwater, very important for the design of pumps. It's a term that we should all be aware of, although I don't think when you're designing a system or whatnot, it comes into play too much. When the impeller is at its maximum diameter, that cutwater is at the smallest dimension it can be. And that's very important for the efficiency of the pump and recirculation and all that. The engineers that design these pumps are very conscious of that. So some common terms, some common components in our industry. I mean, and it kind of makes sense, but I did at least want to mention this or bring it up. I'm trying to get something out of the way here. There we go. The fluid enters the pump through the inlet or suction eye, right? I showed that on the other screen. And then the impeller spins, rotates, and it flows water. It doesn't scoop water. So if you go back to here, you can see the rotation this way, right, counterclockwise, because you can see the it's throwing the water. It doesn't scoop. Keep that in mind. And then that energy forces the fluid out to the edge of the impeller and out the discharge up the diffuser. So pretty straightforward. You can kind of see a little more of a picture here in there and what we're talking about in that regard. When it leaves the impeller, it's there's a decrease in velocity, but the velocity and pressure are inversely proportional. So and then the decrease in velocity results in an increase in pressure as the fluid leaves the pump. So that's really what it's trying to do, right? Lower pressure on one side, higher pressure on the other, and that pressure that's coming out of the pump has to has to have enough oomph to take care of the system resistance that's out in the system, right? You know, if you think of a very simple system, it's pretty straightforward, but obviously many of the systems you folks we get involved with, you get involved with, are a lot more complicated than that. Here's some typical pipe pump discharge arrangements, not arrangements. So we have the centerline discharge, the green one on the left, and then the tangential discharge is on the right. The TACO end suction pumps are centerline discharge, and that was done way back, and that's really to distribute the weight evenly on here, so we feel it's just a little stronger component. And centerline is self-venting, right? So any air that gets entrapped in here can it's I think one of the reasons why a lot of manufacturers use the tangential, that's a word you can look up, right? But this one's tangential. But I think in the old days that had a little higher efficiency than the one the water has to stay in here a little longer. If you start thinking about your flow calculations or head calculations, you can kind of think outside the box there. But nonetheless, those are some of the pumping discharge arrangements you might see in the industry. TACO has its end suction pumps. So we have the FI CI series, and you know, the red guys, the green guys, they have their models of them as well. So the CI one, which is the one up top, it's a closed couple design, right? No base, very small footprint. A lot of people mount it in packages or whatever. Motor bearings is the pump bearing. So the motor, when we say closed coupled, what that means in our engine is the motor is attached to the impeller. Rich, you still out there?
I am. In fact, we got a question that just popped up, if you've got a second.
Okay. Yeah.
So the
What's the
question is,
question?
how does the centerline pump self-vent?
Great question. It is a little misleading by saying it's self-venting. What we're saying is that if there's any air in the fluid, right, in the water that's entering the pump, that air is not going to, that air in a, what we mean by self-venting is it's going to rotate around in that impeller, right? Let me go back to this picture here. If you think about it, right, if air comes in and it's in the water, it's going to find its way out naturally because it's able to right here. But if you have this type of pump and the air comes in, it possibly could get entrapped up here because it's going to find its way to the highest point. So that's what we mean by that definition.
Yeah, and then the pump on the right actually has a plug to open it up to let the air out.
Right. I mean, this plug here is for a pressure gauge. This one here would be to let air out during different maybe startup or at some other time when that pump's in operation. Another advantage of the CI pump is you don't need any alignment required. Smaller flow rates. Well, for quite a few jobs, that's not too bad. And it is the dry shaft design. That means that the water does not get into the shaft. Probably more common for most commercial applications, especially in the States, is the end suction pump, the base mounted pump, the FI pump, and there's many other models out there. It's got a flexible couple design. There is a bearing assembly that separates the motor and the impeller shaft, or the bearings, the shaft goes into there, right? Flow rates up to just over 4,000 GPM. Sealed bearing assembly, right? So the sealed for life bearings in there. We have a VFD rated coupling, and again, that shaft is a dry shaft. Here's some of the other terminology for the components right here, right? The base, very sturdy base. Drain pan. The drain pan is shown right here. Keep in there, you can pipe at the drain. And that's a standard on the Taco pump. There's the suction shown right here. The discharge, and again, they're mostly flanged and whatnot. The casing, the volute, the wet end, whatever you want to call it. And again, it's I think it's cast iron class 48, some spec like that, and that's pretty common in our industry. There's the bearing frame. We're going to take a little closer look at that. The motor. There's different motor manufacturers. I think Baldor and WEG are two of them, US Motor, but there's plenty of other ones out there. And by the way, the Taco commercial pumps, we send them out with what's that fancy the thing that helps the motors for straight currents. God dang it, I forgot the name of it. I'm sure someone will type it in because one of our reps who's on can help me. I'm having a brain fart here, but it has the brushes in it, so the currents do not affect it. Grounding rings, shaft grounding rings. Who saved that? Thank you, Jordan. I appreciate that. Shaft grounding rings. Very, very important for motors nowadays. It could affect your warranty and whatnot like that. Get some more information of that. Get comfortable with your pump manufacturer rep. Hopefully it's a Taco rep, so you understand that to a greater degree. And then there's a coupler guard with that. And do yourself a favor. If you're ever in the field and you see a mechanism running or rotating and the guard is not there, first off, don't go over and look at it with your tie or long hair or something. Tell someone to put it back on. It's just strange. So someone just mentioned.
I have a couple of quick questions.
Yeah.
One I think is asked by a lot of people, but it says, how do you decide when to use a close coupled and when to use a split coupled pump?
I would suggest, and Rich, you might be able to want to pipe in as well. It's really more based on what your environment is. But to be quite honest, I think commercially, Most people use the base mounted pump for most applications. It goes a little higher there. Plus you can change seals without having to pull the motor off and stuff like that. Wouldn't you agree with that, Rich?
Yes, I would.
Most commercial jobs, unless you're putting it on a package or whatnot, you would see the base mounted pumps.
And we also have another question, which is, let's see.
Yes.
Should these bases always be grouted? I like that
Yes.
question.
Yes. It's a simple answer. Yes.
Yes.
We have a procedure spelled out. There are some pump manufacturers that won't even warranty their pumps. HVAC hydronic pumps, if they're not grouted. And why do we do it? It keeps the base from flexing to prevent misalignment issues and provides additional vibration isolation. And to be quite honest, I think that little note at the bottom is one of the things that causes our industry some headaches, and some of the folks that answer phones not often done enough in the field. So yes, they should be grouted, and the bigger the motor, the more important it is. I'm not saying it's not important for the 5, 10, 15 horse motors, but it's really important once you start getting the bigger motors. And there's a whole procedure on doing that as well. Would you agree with that as well, Rich?
Yes, and in fact, one of the benefits of grouting, which Brett had already mentioned, is that it stiffens the base. And the stiffer the base, the less likely there is to be distortion in the base causing misalignment. And, you know, automobile manufacturers, they build cars, and like every year they make the they don't call them frames anymore. I think they call them unibodies. But anyway, that's one of the things that they also try to do is make it as stiff as possible, so that when you're driving down the road, the car doesn't want to wander off to the left or to the right.
I thought you were going to tell me they want you to grout those, and that'd be hard.
Well, the electric cars need to be grouted.
Yeah. I was driving. Anyways, here's the bearing and frame. It kind of, shows some different components there. The Woods Duraflex coupler, the motor, bearing frame assembly. We have special seals on this end here. To prevent stuff from getting into this cavity. Sealed for life bearings, highly recommended nowadays. There's a little cutaway showing the mechanical seal. Can't emphasize enough how important it is to install your system correctly, install the pump correctly, start it up correctly, and if you do that, the seals will give you a long-lasting life. But a lot of times that's not the issue. But you can get a whole big. I mean, you can almost spend an hour or two talking about mechanical seals and the different types and whatnot. And there's the impeller shown there as well. Taco has standardized on the Woods Duraflex coupler, the one on the left, and that's very, very good for VFD applications, which is what, let's be honest, 80, 90, 95% of our jobs are out, right? Superior for variable speed applications. The old standard, the one on the right that some folks still use, and it's used in our industry, and in the right application, it works great. It's not necessarily that good for variable speed applications, because of the constant loading and unloading causes that black piece to actually premature failure. You'll start seeing dust on it. So, just some more education in that regard. So there you go. Here's some other styles of pumps. These are inline pumps, split or closed coupled. Suction discharge are inline, differentiated by shaft orientation. So the ones on the left are horizontal inlines, and the ones on the right are vertical inlines. So the inline pumps, the smaller ones, the 16 and 1900, 16 on the left, 19 on the right. Smaller applications, maybe 200-300 GPM, and you can see some of the applications that they're good for. Boiler pumps, primary pumps, domestic water, but nonetheless, not as much as, they're a lot smaller. One thing that's very important both of these are designed to be self-supporting for that motor. So do not, and it's right in the instruction sheets, do not support that motor with some type of U-bracket or whatnot in that regard. It's very, very important. That you'll get that out of alignment, sure and heck, and that's going to cause premature failure. I can almost guarantee it.
So Brett, we do have a relevant question here.
Yeah. Yeah.
And I think this is an important one. It says, are horizontal and inline and vertical inline built different, or are they just rotated on their side and called something different? And the
Great
initial
question.
answer, they're definitely
but-
built differently.
Yeah, they are built different. I'm going to show you a picture that adds to the confusion a little bit, but they are built different. So the horizontal inline and vertical inlines are totally different. They're not just rotated on their side at all. These guys over here, the vertical inlines, this one here, the split couple one, goes up to over 15,000 GPM, right? These guys here, 300-400 GPM or less. So a big difference in that regard. The closed couple design, standard flush line seal, you can see it there, but you must remove the motor to change the seal, okay? So I think you can get these guys up to roughly 60 horsepower, but really, once you got getting 5, 7.5, 10 horsepower, really educate yourself and start specifying the split couples. They do cost a little more. I think if we think practically, you can, right? Because you got this spool here and some other components, but really from a maintenance standpoint and overall acceptance, it's really important to do these. So split coupled, closed coupled, and the seal can be replaced without removing the motor. And really, they have a lot of applications, medium to large HVAC and whatnot.
So here's another great question. Are flex
Here's a
connectors,
picture of a, yeah.
are flex connectors recommended for inline pumps?
I'm assuming he's talking about the pump. Rich,
Yeah,
I would think.
I think the question popped up when you had the vertical inlines on the screen, the close coupled and the split coupled.
Yeah, if you look at here, you can see it's hard piped right in. So I would not recommend those. They need to be, they do move, but no, yeah, correct. So to re-answer that previous question about inline and vertical pumps, the KV pump can be mounted horizontally up to 15 horse. Most applications they're not horizontal, they're vertical, but it can be mounted horizontal. But you can see here, so here's a flex coupler right here. So I guess the answer, as long as it's allowed movement in there, I have to look at the installation sheets. What would you say, Rich, in that to answer that question better?
Well, it does depend on how the pump is supported, and we do have some guidelines in our installation manual, which will help people
Right.
understand whether or not you need to have flex connections.
Right. Here's a couple KS pumps. You can see one's supported here. You know, there's that's a suction diffuser on one side and whatnot.
Brett, you seem to be breaking up
shown
again.
here. Some installations. Yeah, I don't know how to help. I don't know what to do to prevent that. I mean, I have it on the computer. Does it sound like I'm breaking up to you too?
Occasionally, yes.
Yeah.
So listen, here's what we'll do. If somebody misses something in terms of Brett's presentation, just type into the questions to repeat that last section. That way we'll know for sure if you needed to have it repeated. It's you seem to be okay right now, but there were a couple of periods of time where it broke up, Brett.
I mean, I'm plugged in, I'm hardwired in.
Did you try putting your finger in the electrical outlet?
Yeah.
You know, now it's really choppy. We can't hear you at all.
pictures of some other pumps, the split case pump, and they're pretty big. We have the horizontal.
Brett, you're completely gone. We can't hear you at all. So let me do a quick test for my audio. Are you folks still able to hear me? Yes, okay. So we're having technical difficulty with Brett. Let me see if I can contact him. Hang in there, folks.
Was gone and now I'm back. I don't know if I'm back or not, Rich. I have no idea. It keeps
I
kicking
can
in
hear
and
you
out.
now.
Yeah, it was gone for a while, wasn't it?
Yeah. Will you,
Yep.
did you you didn't stick your finger in the electrical outlet, did you? I was only kidding about that.
Yeah. So really, we are seeing people consider these for condenser water applications, especially if if that tower is being mounted not up on the roof but on the ground level, you know, the lower it needs to be, the dimension between the center line of the pump and the center line of the tower is lower and lower. You may want to consider one of these pumps instead for that application. It can save you a lot of hassles. And here's how they work. So if you look close, there's bowls here, and each one has an impeller in it. But the water comes in and scoots up the bowl and out right there. So that's what you need to do. Here's kind of the breakdown of the ranges of the pumps in that regard. We consider ourselves the best in efficiency after our redesigns on the vertical inline pumps. Here's some basic rules of pumping. Suction pipe diameter should be equal or greater than the inlet. So, you know, don't play any games. If you got a 4-inch inlet, don't use a 3-inch pipe going to it. Use 4 or bigger in that regard. Eliminate as many elbows mounted on or close to the inlet nozzle of the pump. You know, I know we all need to save space, but you want to eliminate as many elbows as possible, and maybe make sure you put that suction diffuser on there. And then ideally include 5 to 10 pipe diameters. I know most of you guys, most of you folks are laughing at that because there's no space for that to take place. Make sure you eliminate the potential of air pockets in the suction piping, and support piping to ensure it does not cause strain on the pump casing. You can see that from some of the pictures, right? So some stuff to consider, you know, basic stuff during installation or on your MEP detail drawing. It is critical to pipe away from a pump to eliminate pipe strain. All right, you can kind of see this here. They're piping away from the pump. All right, they got a nice support under the suction diffuser. They're piping away. They're not piping down to it, right? You can see they're going to make connections above that. So something to consider in that regard. You know, we try to recommend that, but it's not always done. So something very, very important in that regard. So just keep that in mind. Why do we need to align pumps? There's so many reasons why the pump needs to be aligned. Noise, bearing loading, coupler damage, additional power consumption. You're going to wear your mechanical seal a lot quicker. Then you're going to change the clearances, and you might get some rubbing and whatnot. So pump alignment is critical.
So we have a great question here, Brett.
Yeah.
Why do we mean, what do you mean away? Isn't all pipe away from the pump?
Yes, great. I'm going to try to better explain it. But what I'm saying is, if you notice here, right, you can see piping going away from the pump. But what you don't see is the piping coming down from above, right? So a lot of times, if you think about it, sooner or later there's going to be another connection to all these 5, 6 pieces of pipe that you see here. A lot of times what people do is they pipe down right to that pump and make the connection instead of doing what you see here, starting in that direction. Is that what we're talking about, Greg? Greg, Rich.
Let's see. No, he said install from the pump.
Yeah.
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 So let's see. That came in from Matt. Matt, hopefully we answered your question. If not, pose another question and we'll try to provide a better answer for you.
Yeah.
No, he said the answer was good.
Yeah. I see Mark is still saying he doesn't understand. Again, what we're saying is that this piping's done first before you do the piping coming down from the ceiling or down from the piping above and connect right to it. So that's what we're trying to do. And here is when it is recommended to do pump alignments, right? Initially actually the first one is 2, right? The manufacturer does it. I'm sure, I know Takeo does. And when the rep gets the pump. After the pump has been set in place, very important to align it then, because, after it's set, boom, and before you connect to it. After the piping done and system is filled, it should be realigned again. And after pump is run at operating temperatures, right? These are all times when it's a good idea to recheck that alignment, okay? And during PM, preventive maintenance, right? It's good to check it. Us pump manufacturers may be overly cautious, but alignment is really a big problem for a lot of things on here. Some other recommendations or stuff we need to consider. Make sure your pump has a pressure gauge on the discharge side, okay? A lot of people can connect them to both sides with valving, but really pressure gauges are very, very important. And it's pointed out to a lot of folks in the audience at different times, and Rich likes to mention this. Make sure the pressure gauge is the right scale for the numbers you're expecting. Don't get a 0 to 500 range gauge if you're expecting 40 or 50 psi. You're going to have a hard time reading that in that regard. So that's why.
Yeah, and there's a very simple calculation you can do in your head when it comes to selecting a gauge. Like you just said, Brett, if the actual pressure that you're wanting to measure, say, is 50 pounds, then you would select a gauge that had a 0 to 100 pound range, because 50 pounds would be in the center of the gauge. So if you think of 0 on the left side of the gauge, lower left corner, and then say the 100 is in the lower right corner, when the needle is vertically upward pointing to the center range, that would be the ideal gauge arrangement. And like Brett just said, don't specify a gauge that has a 0 to 500 pound range and expect to read pressures that are 1 or 2 pounds. It just is way out of the capability of getting an accurate
read. Think about the clock. You want your gauge to read 12 o'clock.
12 o'clock, right. This is like those World War II movies where the planes are 12 o'clock high.
So true. I see someone saying, why do some pumps not require alignment? That's another reason, personally, if I was on your side of the fence, I would strongly consider specifying these types of pumps here. The vertical inline pumps, the KV and KS Takeo models, and others, right? There's other models out there, and you're not single sourcing. We're not the single source. We'd like to be, but we're not. They do not require field alignment. They are bolted in strong. This is a hard metal coupler that connects these two shafts, and it's bolted all right up. So something to consider, something to think about from a installation project standpoint. Consider getting some ideas or getting more information if your company has always specified base mounted pumps, and there's thousands of them out there, hundreds of thousands of them, and they work fine, and don't get me wrong, but the industry is leaning in this direction more and more, and Rich has some great stories about talking folks into going to these types of pumps and some folks really enjoy them. Not enjoy them, but they're happy that they did make that switch in that regard. What else? What else? Flow control, okay? And you know, in our industry, VFDs, right? But always never put a flow control valve on the suction side of the pump, okay? Only on, if you're gonna start frigging with flow control with a valve, put it on the discharge side, right? I think it's illegal as far as ASHRAE is concerned, but on the suction side, it's a shut-off valve for maintenance, but you need full throttle going there. Do not control flow on the suction side of the pump, only on the discharge side. Can't emphasize that enough. VFDs nowadays, we have a whole presentation on VFDs and self-sensing pumps and whatnot, but I think over 5 horse now, 5 or 7.5 or something relatively small, you have to have a VFD. So variable frequency drive, you know, and that's another whole conversation in how to properly design those or install them, I think is more important and whatnot. And then you can trim the impeller. You can trim the impeller for flow control, and that your TACO rep or a rep can help you. You can kind of start thinking about the different diameters of impeller based on the affinity laws and whatnot, but nonetheless, you can control it with the impeller. Probably not done too often anymore, right, Rich?
Yeah, I mean, most applications today use variable frequency drives.
Right. But there are times, even the VFD can't save our butt because of the of maybe the lack of head loss in the system. But that's another whole conversation that we could get into. And here's just a recommendation. You know, go check your specs. You know, your design drawings, your details. Maybe consider using gate valves at the pump suction because they don't offer any resistance to flow and can provide a nice tight shutoff. Many times in the world out there, butterfly valves are used. All right, you know, they do offer a little resistance and potentially could be a source of hangups if something's in there, which would be critical at the suction. So something to consider in your shutoff valves in that regard. Here's some common installation problems. You could see a startup strainer left in the suction diffuser. That would reduce pump performance and cavitation and possibly cause cavitation. So there's a fine mesh strainer that comes in the TACO suction diffuser, and possibly during startup, if you don't take that off, take that out, not off, out, and you have to take it apart and take it out, that could cause some issues there. Balancing, right? I'm sure many of you, if not most of you, have had balancing issues, right? So that could have excessive flow, which may cause cavitation. Excessive flow, if you're too far out on the curve and that NPSH curve is way up high, that could be, you know, you could cause some issues there. So that could cause you some velocity noise, or you trip the breaker because you're having excessive amp draw. So really some common installation problems, right? Reverse rotation. Check the rotation. You're going to see no flow, low pressure. The pump is rotating backwards. So really, these are all in the startup definitions or manuals that pump manufacturers have, but nonetheless, it's out there. You know, so just consider that reverse rotation. Alignment, right? We talked about alignment and whatnot. Most TACO reps offer that service, so make sure you consider that in that regard. But you could have a lot of issues, you know, in that regard. So something to consider. No pipe stand under suction diffuser, right? So if that thing's just hanging there, you can start getting things out of alignment. So some stuff that could cause some installation issues in that regard. Over lubrication. Nowadays we've standardized on sealed for life bearings. They have an L10 life of way over 60,000 hours, so they don't require lubrication. But sometimes people over lubricate bearings, and that could cause issues in that regard too. Leaking mechanical seal. A lot of times that's caused by running the pump dry. Maybe during early, someone runs it dry, that you're sure in heck you're going to do it. Consider adding to your mechanical specs that the pump supplier or the contractor buys an extra mechanical seal or two. And that way they're already on site, and you have them before it's an issue, right? There's nothing worse than trying to get off a job and the seal's leaking. So something to consider in that regard. And these seals aren't designed for startup, right? They really should be a nice clean water application. So something to consider. So very quickly you can destroy that. And poor water quality is probably the key factor in reducing the seal life. Sometimes shafts are torn apart, the lack of a check valve, and the water comes back down and rotates it, and it could actually crack that shaft. So some other important design issues that you need to make sure you take into account in that regard. I'm getting close to the end, Rich. Before I go through this one, we got some more questions. What do you want to talk about?
Yeah, we do. We have a group of questions here. Let's try picking a few. They're very good questions. So let's start with this one. Is there a pipe size you would say to use gate valves versus full port ball valves? And I believe the cutoff is 2-inch. If someone else knows the cutoff dimension, pass that along to us. But I think 2-inch and lower, you would typically use a full port ball valve. And then above 2-inch, say starting at 2.5-inch and above, you would use either a gate valve or a butterfly valve.
I don't see many ball valves bigger than 2-inch on most applications. So yeah. I would tend to agree. With that.
Yeah, so Bill commented, he said 2-inch and less for ball valves. So that sounds correct. All right. And then we also had the same comment from Preston. So let's keep going with a couple more questions. A local engineer says a suction diffuser is not required on variable frequency drive pumps. Please comment.
Wow.
I would have, let me try my quick answer, and then you can give them your answer also, Brett. But essentially, the main purpose of a suction diffuser has two purposes. One is to change the direction of flow from, for example, from vertical to horizontal, in which case the suction diffuser does that nicely because it has internal flow straightening vanes. And the other major function of a suction diffuser is that it acts as a strainer. It has its own strainer. So it really is not an issue relative to variable speed pumping. It really has more to do in terms of how the piping is connected to the pump, and also whether or not you're interested in having a strainer. If you do not want a strainer on the suction side of the pump, you might consider using a long radius elbow. So that's a couple of quick answers there. Anything you want to add to that, Brett?
I mean, I don't think that there's a direct correlation between the VFD speeding up or slowing down a pump and having the suction diffuser. The suction diffuser, it keeps stuff out of the pump because they have strainers in them of some sort, but its main job is to provide nice, or help provide nice, clean laminar flow into the pump, right? So by slowing the pump down, if you had a tight elbow right on there instead of a suction diffuser, I wouldn't. I agree with everything you said. That's for sure. I don't see the correlation between the two. I'd have to get more information from that.
Okay, let me just read a couple of other quick questions here. Let's see. I was just reading one a second ago. There's so many questions, the thing keeps jumping in front of me. We already talked about the full port ball valve, talked about the 2-inch size. Okay, here it is. Are your motors all capable of being hooked up to a variable frequency drive? And I think the answer there is that you should always specify an electric motor that is inverted duty capable. I mean, in most cases, almost without exception, and I don't want to say 100%, our motors are compatible with variable frequency drives, but it's always best to specify whether or not the motor is required. And sometimes the phrase is inverted duty motor. You can use that. Let's see, what else have we got here? Is it better to put the check valve before or after the pump? Why don't I let you take that one, Brett?
I would recommend before the pump. You don't want the water. When I say before the pump, before the suction side of the pump, obviously.
Well, no, I think, let me reread the question here. Is it better to put the check valve before or after the pump?
Oh, okay.
Check valve
Yeah.
should always go after the pump.
After the pump, because you don't want the water to be able to flow back into the pump, right? So if there's no check valve there, and so think about one of these pumps, the FI pump, where the discharge is straight up, right? So that pump's going up, to wherever it connects, or the piping's going up to wherever it connects. If you shut that pump off, all that water could come tumbling back down into the pump and cause that pump to rotate in the wrong direction. It actually could break the pump or break the shaft. So it's on the discharge side of the pump.
And if you have two pumps running in parallel and you don't have check valves and one pump's running and the other one's not, it'll just recirculate through the pump that's off.
Right.
Okay. Let's see what it says. What is the advisable safety factor and percentage in sizing boiler pumps? That's a great question. I don't have an answer for that, Brett.
Check with your boiler manufacturer.
Yeah, I mean,
that's a great question.
That's a great question. Sure.
Yeah. I always say, anytime someone asks me that, I always would want to know who's the boiler, what type it is, and what's their recommendation. And I would hate to be the person to make that comment, if you know what I mean.
So this will be the last question before you continue. Yeah. We have some great questions here. We're not going to get to every single one of them, but this one's kind of interesting. They say, have you ever seen cavitation on a closed loop system? And then it went on to say what caused it. And the answer is yes, you can have cavitation on a closed loop system. And if
you know what, Rich, next week, our next class is on NPSH, March 26th. And that you may get into that a little more.
We will. But the short answer is that it's possible to have cavitation on a closed loop system when you have a very high temperature fluid and you also have a very low pressure on the suction side of the pump. I actually had a project about 5 years ago where that's exactly what the problem was. The pump was cavitating because they had a very high temperature on the suction side of the pump and a very low pressure, and the pump was cavitating. So I'm going to turn it back to you, Brett, so you can wrap things up, and then if we have some time, we'll answer some more questions.
Yeah. These bullet points, we've pretty much already talked about them, but these guys, our pumps, centrifugal pumps, rotodynamic pumps, circulators, surge-free laminar flow, right? Turbulence can cause reduced efficiency, wear and tear on the bearings, seals, and other components. So surge-free laminar flow, we talk about that 5 to 10 pipe diameters. We talk about a suction diffuser or something, long radius elbows, so something to consider. And in 2 weeks, a month plus, the 26th of March, we're going to be talking about MPSH, net positive suction head. And if you're not careful, this is what it could cause to your impeller. So come back and talk to us in a couple of weeks. Any other questions you think we can cover? We kind of got a late start. I know
Yeah, I was going to
many
say,
people.
Brett and I can hang in here for a few minutes and try to answer some questions. We know that some of you have a kind of a hard stop at 1 p.m. We apologize for the technical difficulties. You run into those things in the world of computers periodically. So we do have some new questions out there, and we'll hang around for a few minutes and try
Yeah.
to answer as many as possible. And we know that some people will move on. So let's see what we've got here. Let's see, what is it? We talked about the boiler flow. We talked about the cavitation. I'm reading through quickly. Why don't you read them also, Brett, and see if there's some
Yeah,
that
yeah.
haven't answered.
So Samuel said, how do you over lubricate a pump? It's really the most times it would be that bearing frame on the FI pump. People would just keep if there's a fitting there. Sometimes people will just they hear something else going on. They think it might be that, and they keep putting grease into it. So that's one way a pump can be over lubricated. Somebody's asking how to get your credit. About 24 hours from now, an email will be sent, and you can download it right from there for your PDH professional development hour credit.
So we have one comment here. What would be a good software to size pipes or select pumps? Well, we can definitely steer you in the right direction. We have on our website actually we have a new selection software that's available, but we also have the selection software that we've been using for a considerable period of time. So you can do your pump selections online using our software. So that's an easy one. Let's see. Oh, here's one. Here's a great comment here. What about a triple duty valve on a VFD controlled pump as opposed to a flow meter for flow verification? Well, my first response is that it's always best to use a calibrated high quality flow meter for determining the flow in a system. The multi-purpose valve does have taps on it for measuring pressure differential to determine flow. But I would, prefer for precise measurement to use a flow meter that has been calibrated and it's a high quality flow meter. Because the multi-purpose valve gives you a pretty good indication of the flow. But I would definitely try to get a calibrated flow meter in there. Any other questions,
Yeah.
Brett, that you can see?
I think we're getting a lot of people leaving, so I think we should cut it down.
All righty. So at this point, I'm going to say thank you very, very much for listening to our presentation today. We apologize for the technical difficulties. We'll work harder at making sure that that doesn't happen in the future. Any last words before we sign off, Brett?
No, 24 hours, the recording and your PDH certificate should be distributed, and hopefully we'll see you on the 26th of March for the next one. And again, thank you everyone for participating. Thanks, Rich.
Thanks a lot, folks. Take care.